be wondering why I was playing that song. Well, I'm going to have a story for you, and you'll hear it a little bit later. This lesson is about the law of cosines, and we'll also be talking about using Heron's formula to find the area of a triangle. Last class we talked about solving an oblique triangle. Remember, oblique just means non-right. And in order to solve a non-right or an oblique triangle, you need at least 3 pieces of information. It could be angle, angle, side, angle, side, side, angle, which is the ambiguous case. We talked about that last time. And in those situations, you use the law of sines. Now we're going to be talking about the law of cosines that you would use if you had side, 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 and side, angle, side. So what is the law of cosines? Well, it looks like this. C squared equals a squared plus b squared. Hey, that looks like the Pythagorean theorem. But wait, there's more. Minus 2 times a times b times a cosine of angle C. A couple of things to pay attention to here. Notice that the letter that I start with in the formula is the same letter that I end with in the formula. So if I had a triangle DEF, for example, and maybe I started with d squared, then that could be equal to e squared plus f squared minus 2 times e times f times the cosine of angle D. So as long as you recognize the pattern of the formula, it's pretty easy to come up with it. Another thing to pay attention to is the fact that this is all one term. You want to make sure that you follow the order of operations. A lot of students want to do a squared plus b squared, and then they subtract the 2ab, and then they multiply all of that times the cosine of C, and that would be wrong because you have to do multiplication before you can do addition and subtraction. And I could also take this formula and isolate the cosine of angle C by subtracting the a squared and subtracting the b squared and then dividing it by 2ab. I'd have to do some fancy work with the negatives, and I would end up with this formula. This formula could be useful in the side, side, side cases. I wouldn't recommend that you memorize it, and I'm not going to use it for any of my examples today, but it's there for you. Okay, so here's our first example, triangle DEF. We want to find the measure of all 3 angles. I have a tip here to find the measure of the largest angle first, and we'll talk more about that later. The largest angle, of course, is going to be the angle opposite the longest side. So I'm going to start out with 19 squared equals 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of angle E. And then I'm going to subtract the 8 squared and the 14 squared. So 19 squared minus 8 squared minus 14 squared equals negative 2 times 8 times 14 times the cosine of angle E. And then divide. So 19 squared minus 8 squared minus 14 squared, all divided by negative 2 times 8 times 14 is equal to the cosine of angle E. Now you're going to want to type all this into your calculator. I would recommend using the stacked fraction feature of the TI-84 so you don't have to deal with parentheses. And you're going to get a decimal. It's going to be about negative 0.45 something. And then do the inverse cosine, and you're going to get the E is approximately 116.80 degrees. All right, next up, I'm going to find, let's find angle F. So I'm going to do 14, separate that. Over the sine of angle F. Oh, I'm using the law of sines here. I could use the law of cosines, but the law of sines is often more efficient. So 14 over the sine of angle F equals 19 over the sine of 116.80 degrees. And when you cross multiply and divide, I'm not going to go through those steps. You're going to get about 41.12 degrees. And then once you have 2 angles, it's easy to find the third. Just subtract from 180. So angle D is 22.08 degrees. Story time. So why was I playing that In Sync song at the beginning? Well, around the year 2000, it was early in my teaching career. I know you can't believe it because you can't believe I've been teaching that long, but I have. The song Bye 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 by In Sync was very popular. It was playing on the radio all the time. And I was teaching the law of cosines to my trigonometry class, and I had a student in the class. His name was Alvin. And every time I said side, 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 he would sing side, 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 like to the tune of the song. And I suffer. It's torturous. Every time I say side, side, side now, I think about that In Sync song. I suffer, and so now you're going to suffer because I've just told you this story. All right, one thing you want to be careful about with the law of cosines is you might end up with an ambiguous case situation. In order to prevent it, if you have side, 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 then you're going to want to find the largest angle first. If you have side, angle, side, after you find the third side, which is the only thing that you'll be able to find, you're going to find the smaller of the two remaining angles next. Let's take a look at this example. I would recommend that you pause the video here, try this example on your own, and then check back and see if you got it right. All right, this is a side angle side situation. So the only thing that I can find to start with, it would be little a. So little a squared is equal to 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of 115 degrees. You can just type all that in your calculator in one big step, and then take the square root of both sides, and then you're going to get that a is about 21.26 centimeters, like so. We also want to find the missing angles, so I'm going to use the law of sines to find the missing angles, and I said to find the smaller of the two remaining angles first, so that's going to be angle C. Yeah, angle C. So we're going to do 10 over the sine of angle C equals 21.26 over the sine of 115 degrees. And so that's going to be, when you do that math there, I'm not going to show all those steps, you're going to get 25.23 degrees, 25.23 degrees there. And then to find the other missing angle, you can just subtract from 180 degrees, and that's going to end up being 39.77 degrees. Okay, here's our next example. Again, I would recommend that you pause the video and try the problem on your own first. So we have another side angle side scenario because we have that this length is 43, this is 60, and then the angle right there is 45. So first I'm going to use just some letters here so we can kind of get our minds around what we're doing. So h squared is equal to f squared plus p squared minus 2 times f times p times the cosine of angle h. Now I can plug my numbers in, so that's going to be h squared is 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. And then when you do all that in the calculator and take the square root, you're going to get the h is about 42.43 feet. Okay, again, on this example, I suggest you pause the video and try it by yourself first. All right, the challenge on this one is to try to figure out what it is that they're asking for, because they said the bearing from point B to point C. So remember, for bearing, we have to think about due north. So let's say this is my due north line right here at angle B, and we want to go from B to C. So we're looking at, that's the angle that we're looking for. That's the bearing. And then this angle right here, of course, is going to be 90 degrees because it's with the horizon. So I'm going to find angle B first. That's going to be that big obtuse angle right there. And then we'll subtract 90 to get the bearing. So since I'm looking for angle B, I'm going to start my formula with little b. So 139 squared is equal to 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of angle B. And so from here, I'm going to do 139 squared minus 60 squared minus 80 squared. I'm going to go ahead and divide all that by -2 times 60 times 80 equals the cosine of angle B. And then you will do all that in your calculator. And again, I would recommend with the stacked fraction, and then you'll get a decimal, and then you'll do the inverse cosine. And so angle B is going to end up getting you 166.15 degrees. But again, that's not the what answer they're looking for. They're looking for bearing. So the bearing is going to be 166.15 degrees minus 90 degrees. And that is 76.15 degrees. Duh. 15 degrees. But we need to put some direction on there. So that's north 76.15 degrees east. All right, the last thing we're going to talk about is Heron's formula, sometimes called Hero's formula. You can pause the video and read about it. But this is your formula. The area is the square root of S times S minus A, etc., where S is defined as your semi-perimeter, and like the name suggests, a semi-perimeter is half of your perimeter. So write that formula down. And now let's take a look at the example. So first thing I want to find is the semi-perimeter. So that's going to be a half times 43 plus 53 plus 72, and that's going to work out to be 84. And then for the area, we're going to do a half, square root, giant square root, 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. And when you work all that out, you're going to get about, let's see, area is about 1,131.89 square meters.